Okay, everyone. So today we come to chapter 2. We finished 1.8 with quadratic functions. I would like to introduce chapter 2 with cost, revenue, and profit functions. So in 2.1, we will talk about application quadratic function. We will focus on revenue functions and profit functions. We did learn about the cost functions and price demand functions in the first chapter a lot, right? As you remember, for the cost functions is made by fixed cost plus with the variable cost and multiplied by the number of items there, which is X. Yeah. So this is the way we can produce a cost functions. And as you see there, the function is the cost function is actually is a linear function, right? Since it have like, fixed cost is a y-intercept and variable cost is, variable cost at v here as a slope, right? So what about price demand function? We have price demand functions in the form as p of x equals to m minus nx, and where p of x is price per unit and x is number of unit. And again, this is a linear functions. With the slope is negative n here, right? And the y-intercept or the p of x intercept is going to be the n. Okay. So we did learn a little bit about revenue function, how it look like, and profit function, how it look like as a parabolas, and you see in a previous chapter. Okay. So keep in mind that revenue functions is the number, so we're gonna be x times p of x. All right. So as you see, p of x was in the form as m minus nx. So we change the p of x there to be m minus nx. So then we can have the function of revenues will be as x times m minus nx squared. And you see there, we have the x squared term, which can tell us that this is a quadratic function. Yeah. Okay. And quadratic function is, as you know, that it's going to be a parabola downward, right? Parabola downward. Okay. All of this. And the last one is profit function. And profit function, as you know, that profits will be revenues minus costs. So then we will use the revenue function there minus the cost function there. Okay. So since revenue function have x squared term, so it must be stay x squared term in profit function, and it's gonna make a quadratic function. All right, and also it's gonna be a parabola downward. Okay, but we're gonna talk deeply in that later. And there's some special case that revenues and profit function become a linear function when a equal to 0. Okay, but anyway, let's start with example 2.1, publishing a book. Okay. All right, so if the prime function is p of x equal to 200 minus x, we need to find the revenue functions, and then price and the revenues are in dollars, and x is a number. So then we want you to plot. So let me see. Find the revenue functions and then plot the revenue function. Okay, so I would like to start with find the revenue function. All right, let's say find revenue function, which is r of x. And you remember that up here I give to you the formula was r of x equal to x times p of x, right? It's gonna be equal to x times with p of x. All right. So we need to know what is p of x. P of x equal to 200 minus x there, right? So I just need to change that to be x times with a group of 200 minus x. Okay, so I want to make sure that everyone see the 200 minus x there, right? Okay, so we have the revenue function can be in factor form there, or if you want to if you want to change it to be a quadratic form, you should write as it should distribute it as 200 x and minus x squared, or you can write as negative x squared plus with 200 x. So this is quadratic function with a equal to -1, b equal to 200, c equal to 0. And keep in mind that since a equal to -1, which is less than 0, we must have a downward parabola. Yeah. All right. So that is the revenue functions. And I would like to box it to make sure I don't forget that, right? So I could box this one, or even using this one. Maybe two form that could be, could be present for the revenue functions. So let's find the vertex, right? Okay, so since we want to plot the revenues of the function, we need to let's plot. So let me use this one. Let's plot the revenue function. We need to find the vertex, which is h comma k. And as you know that h will be equal to negative b, negative b over 2a, negative b over 2a. Okay, and what is a negative b? Negative b, so put down negative 200 and 2 times with a was negative 1. Okay, so then we must have, using calculators, you must have the answer as negative 200 divided by negative 2, so going to be 100, right? Okay, so we have h is hundreds. That means the value of x for the vertex is hundreds. So what is k going to be? Okay, k equal to revenues with hs input, we equal to revenue of hundreds. That means we have you can substitute into either this form or this form. Okay, so I gonna use this form, hundreds times with 200 minus hundreds, and now I can have case equal to hundreds times with hundreds, will equal to 10,000. So I would like to highlight, or maybe box those. No, highlight better. I'm gonna highlight the H and I highlight the K. Okay. And now frozen. Okay. Now we will have the vertex will be hundreds, comma 10,000. So I gotta mark it first with a 1 point, hundreds and 10,000. That's one. So you can have the you can have that one, and you can find let's find the y-intercept, sorry, the x-intercept. Or the zeros, all right, as we cause in the 1.8 sections. So you can put revenues function equals 0, all right. We want to find x-intercept, then we can let x equals 0, and then we can have, you're going to use the form and factor form here, because we found the factor form. We can apply using the factor form, so it's going to be easier for us to solve it. So x times with 200, sorry, 200 minus x equal to 0. So we have x equals 0 or 200 minus x equals 0. So we can have x equals 0 or x equal to 200. So in another word, x intercept 0, 0 and 200 comma 0, right? Okay, so I gotta plug those 2 points. 0, 0. Yeah, right. I mean, you can make more values to make your graph better, but I just need these 3 points to, to grab my revenues. Let me see here, right? I cannot go more than the maximum at vertex there, right? So you can make some, you can find some more point by the t-values, maybe find what is 50 revenue gonna be, or even you can using the decimal to, to handle that for use, and find the function, say, x equal to x times with 200 minus x. So you can have longer. Okay, so you can see that from 0 to 200 here, right? So I want to make 0 to say 200, and maximum for the y gonna be in between 0 and up to 10,000, maybe 11,000 to make some bounce. Okay, so you can find some values such as like at 50, what happened, like over here. It's not easy to see it, but another way you can do like R of 50, and you right where you get like 5,000, 7,005, that's right. So if you're using, like this, all right. And another one could be like 150. Okay, they're the same. So you must using those 2 points to coordinate in here and then connect those. Okay. Anyway, since we grab by hand, and we need only we do only 3 points, so we just plot approximately, and I don't really need like perfect function at this time. Okay, and keep in mind that we are having a parabola downward with the vertex 100, comma 1,000, 10,000, right? And the two x intercept going to be 0 and 200. Okay, so that will be the case that we want to do the revenue function. All right, so before moving to the next example, I'll name this example 2.1 over here as part A. So I want to change this, right? Part A, right? And then that will make this example example 2.2 here is part B. So we can just take away these and say part B here. right? So part B want us to examine profit. We involve both sale of items and cost to make down. So that means we need to get the cost function. In this guy. Okay, cost function. And we are given that the fixed cost is $6,500, and the per diem cost is $20. All right, so I want to find the cost functions, and I'm having the revenue functions, revenue graph function was grabbed up here, but I just move it down here as the, as the graph perfectly. But I want to include, I want to include the cost function into this graph, right? So I need to get the cost function CX and plot it together with the revenue function graph. So how to find the cost function? As you remember that we know that the cost function is a linear function, which is in term as fixed cost plus variable cost per max. So we can just say C of X will be equal to F plus Vx. And we know that fixed cost is 6,500. I put down it's here. C of X will be equal to 6,500. And then plus with the variable cost was 20 times with X. So I like note that F equal to 6,500, V equal to 20. Okay, so I'm gonna make this one to be black. Okay, so I'm gonna graph. Let's grab CX. So we can have the itself. Actually, let's say y itself. Actually, for the graph of CMX, we can just say set. We can just use the t tables to make it easier for us. Let's make a t tables. And I'm gonna choose 2 points, but usually I'm gonna choose the starting point as 0, and then cost will be when you plug 0 into the function, you're gonna have 6,500, right? And I will use the maximum value for X to get the revenue become 0, gonna be 200, and plug into to that you to the cost function, right? You will have 6,500 plus with 20 and time with 200. So then you're gonna have C of 200 equal to 10,500. So put out here 10,500. All right, so we have 2 points. One is 0 and 6,500. So here is 6,500. And another one is 10,500. So 10,200 and 10,500. So it's gonna be here. So according to these 2 points, I can grab a line, go through these 2 points, like using this. Okay, so let me draw the line, go to these 2 points. Okay. Now it's look okay to me. So we will have this as the cost function, right? We will have the blue one as the revenue functions, and we have y-axis labels, I would say revenue and cost. And the one below the X gonna be number of sold, right? Number sold. Okay. So and the revenue cost is in dollars, right? So that will be the graph we need. You may present some, break and even break even points at these 2 over here, right? Break even. All right. So they are the 2 number approximately right now. It's going to be at as X equal to 50, or I'm gonna say 130s. All right. So this is by eyes. You want to find that, you had to, maybe you're gonna use the decimal to find exactly one, or you had to solve for, okay, that's revenue equal to the cost to find the break-even point. So I would love to show my boss where is the area he or she should get to make the profit positive. So it is okay that revenue function is above a cost. So I would say in between 50 and 130, right? It will make profit. Yeah. So we consider about those area. All right. Now we're gonna need to, okay, so now I would like um, to put a link for the worksheet flip chart. So so that was in, let me show you in our canvas, and open our canvas. So in canvas I have post 0w 2.1. We have that activities here. Please ignore the time, the date here, and focus on the paper. Okay, let me download it. And open this one. Uh-oh, I opened the wrong one. Let me, this one. All right. So we have like an activities with 7 problems, and I would love you to work on this. We are just given with the K that's having the function of price, price in terms of demand, and from there we will find we also given the fixed cost is $950, and the per item cost is $50. So from there you should find the cost functions as f plus vx, which is going to be equal to what is that? F was 950 plus was 45x, as you are given there for the fixed cost and the variable cost. And then for the revenue function, you may have to, you know that it's going to be made by the demand time with the price functions, and you will have to substitute the price function into here, right? So x time with p of x now change to be 150 minus x. Okay, so then you may go ahead and convert it into the quadratic form by distribution. You try that, okay? And after that, in problem number 3, I want you to plot this RX and the cost function. I would recommend that go ahead and try, to put this on desk mode first, so then you can have some idea with that. All right, that was variable function, and we can have the cost function as 950 plus 45, right? So cost functions, let me go to this, all right? And that it. You may have to adjust the values for y and x to make the graph nicer. You know that is supposed to be maximum is 150, and then for the x, and let's see, so x is up to 150 only. For the y, you may get up to, I would say, 8,000. Okay, the reason was as 150, I saw that the cost was up to 8,000 or something. All right. So so this is by decimal. You may have to follow by the way I did over here to from 2.1 to to grab the revenue function, to grab the cost function and put it together. So so the way was there. Okay, what else do we have in the work? So let me see. All right, we want to find the profit function. So profit function will be in the form as revenues minus cost. So you will use the function revenues of that file over here and subtract the cost function that over here. Okay, and then we need to find the break-even point by using quadratic formulas. Break-even points will be indicate that revenue equal to the cost. So you may have to look back to the previous previous session here, 1.8, right? When I did talk about break-even, when you put revenues minus cost and equal 0, and then make the function make the equation equal zeros here, and then find x, which is gonna be the break-even point. Okay, so so that's going to be all of my hint for you guys in here. But you can see, according to the graph, you can see the answer key will be 10 and 95. So 10 and 95 will be the answer key. Okay. And in order to make profit, you know that it should be in between in 10 and 95. Okay. Okay. So so that's the way you're gonna put in here, and in and for finding the profit, you must have the revenue function. I mean, the profit function first, and then plug 50 into it. So in here, I would say profit functions, maybe you will using as x minus 0x. All right. You must simplify it by substitute those two function into it, and then if I like p of 50, in answer key gonna be 1,800. So we'll say answer key is 1,800. All right. So I'm gonna stop this section here, and we'll see you in the next session. Thank you.